In this example, looks like we have the equation y equals x to the power of, and we have a natural log of x up there in the exponent, and we would like to use logarithmic differentiation to find this derivative. So if you'd like to go ahead and pause the video and give this a go, do so and come on back and we'll work it together. Okay, so here we go using logarithmic differentiation, which says the first step that we need to take is to take the natural log of both sides of this equation. And again, we do this in an effort to kind of make this right side a little bit cleaner, because right now we have an x in the base and an x in the exponent, and that can be a little troubling sometimes. Okay, so we're going to say it's the natural log of x to the natural log of x. Okay, what's nice about this is now that we have the natural log of this entire side, this exponent can come out front as a coefficient, and I can now rewrite this as the natural log of y equals, and we have the ln of x, which was that exponent, that's now a coefficient, times the natural log of, well, x. So we could rewrite this, if you wanted to, as the natural log of x squared, since we have two of them. And that might make our lives easier. Okay, so you'll notice also I have written up here a derivative rule for the natural log of some function u. And we can do the derivative of this by saying u prime over u, which is going to be handy when I take the derivative of this left side. So let's go ahead and differentiate both sides of this equation. And so I'll have y prime over y on that left side. And on the right side, it looks like I'm going to go ahead and use chain rule. So the derivative, I'm going to bring the exponent out front, and I'm going to subtract 1 from the power, and then multiply by the derivative of the inside. So 1 over x, just like that. So now let's rewrite that whole thing. So y prime over y equals, there's a few ways you could write this. You could say 2 times the natural log of x all over x. That seems to be probably the most suitable. So remember, we're trying to solve for y prime here, or dy dx. So to do that, we need to go ahead and multiply both sides by y. So on the left side, those cancel, and I am indeed left with y prime equals. But remember, what was that y from before? Well, it's going to be this x to the power of the natural log of x. So if I go ahead and replace that with x to the power of the natural log of x, I'll have a slightly different expression over here. So it looks like it's going to be 2 times the natural log of x times x to the power of the natural log of x all over x. Okay, well, at this point you could probably do a little something, because I notice that I'm dividing these two terms and they have the same bases. So let's go ahead and come over here a little bit and rewrite this. So I have x to the power of the natural log of x and then x to the power of 1. So when I'm dividing like bases, remember I'm subtracting exponents, so I could rewrite this as x to the power of the natural log of x minus 1, and that would be okay. So maybe let's go ahead and do that for this expression down here on the right side. So we could rewrite this as twice the natural log of x times x to the power of the ln of x minus 1, and that will be our y prime. So here we go. We have used logarithmic differentiation, and we went ahead and found the derivative of our equation up here, y equals x to the power of the natural log of x. And that's again what that looks like.